Welcome students. So in today's session we will be looking into the various instructions and the different forms of these instructions that is included in the arithmetic instruction set or that is supported by 8051 microcontrollers. So the first instruction that belongs to the arithmetic instruction set is add a comma source. So here you can see from the beginning itself, uh, in all the instructions that is supported under the arithmetic instruction set of 8051, the destination register should be always the accumulator. Okay, so based on that we have only the possibility to change the available positions or change the positions from which we will be getting the second operand or the source operand. Okay, one of these, there should be two operands for performing any arithmetic or arithmetic operations. So in this, one of the operand will be always an accumulator, and the next other operand will be always can be either an immediate data, or it can be content of a register, or it can be content of a direct memory location which is been specified in the instruction, or it can be a content of the memory location which is pointed by the register. Okay, so the first one is add a comma source, where the 8-bit source an 8-bit source is added to the 8-bit data that is contained in accumulator, and the result obtained is again stored in the accumulator. Okay, and during this particular operation the carry flag and overflow flags are effected basically. So we have the different forms. Add a comma hash data means the immediate data and the content of the accumulator is added and the resultant is stored in the accumulator. Then add a comma rn means the content of the register specified is added with the content of the accumulator and the resultant is stored in the accumulator, which follows the register addressing mode. Then add a comma direct means the content of the memory location which is mentioned directly in the instruction is added to the content of the accumulator and the resultant is stored in the accumulator. Then add a comma at the rate ri means the content at the memory location pointed by the pointer register, that is r0 or r1, is added to the content of the accumulator register and the resultant is stored in the accumulator. So in these cases, after the addition, if there is an overflow, that is if the result is more than 8 bits, then it is indicated by the overflow flag setting, or as well as when there is an carry flag generated, it is indicated by the status updation of the carry flag. Now we have the second instruction in arithmetic instruction set, that is addc a comma source, which is similar to the above instruction. The exemption is that together with the addition of the data from the addition of the data in the accumulator and the other source specified in the instruction, the content of the carry flag at that particular instant is also added. So let's look to the first general format. addc a comma hash data means the immediate data specified in the instruction, that is an 8-bit data, is added with the content of the accumulator and together with the carry flag, and the resultant is updated to the accumulator. Okay, and for the next case, addc a comma rn means the content of the register is added with the accumulator plus the carry flag and the resultant is stored to the accumulator. Okay, and the third example, addc a comma direct means the content of the memory location, direct memory, that memory location specified in the instruction is fetched and it is added to the accumulator with the carry flag value, and the resultant is updated to the accumulator. And in the fourth case, addc a comma at the rate ri means the content of the memory location pointed by the pointer register is added to the carry together with the carry flag and the accumulator, and the resultant is stored to the accumulator register. Okay, so you can see that there is a single instruction add a comma source, but it follows all the five not five all the four different addressing modes that is supported by the controller. Okay, so these are the some of the features which gives you a more stable and a satisfying proof regarding that your 8051 microcontroller basically supports the CISC instruction set architecture. Okay, then we have the instruction sub, where it performs the subtraction of the data, okay, the second operand from the accumulator content with the borrow. Okay, so there is no specific instruction which performs just the subtraction of the content or the data specified with the content from the content of the accumulator without considering the carry flag. So here we have a single instruction for that. So if there is no borrow, the carry flag will be 0. Okay, so if I take the first example, SUBB a comma hash data, the 8-bit data is reduced or subtracted from the content of the accumulator, and if carry flag is 0, then there is no borrow, so it is equivalent to a minus data. But if there is a carry flag, then the impact is seen, that is the borrow information. If there is a borrow 1, it is also minus or reduced from the accumulator content. Okay, so similar to the add, we have the 4 different addressing modes supported by the SUBB instruction or the subtraction instruction. Then the fourth one in the arithmetic instruction is mul AB, that is basically to perform the multiplication. So whenever we multiply two 8-bit values, you will be having a 16-bit value as an product. Okay, so the condition is that here you can only make use of only the two registers A and B, so where they belongs to the same category, but it is not the uh, it is not applicable under the register addressing mode, because when we go for the register addressing mode, the basic definition of register addressing mode is that we can use any of the general purpose registers. Okay, so here you cannot use any other registers other than A and B, hence there is no specific addressing mode defined for this particular instruction mul A comma B. Okay, so here what happens is that the content of the B register is multiplied with the content of the accumulator register, and we obtained a 16-bit value. Of the 16-bit, the lower bytes. Okay, so here you will be having the lower byte 8-bit is stored in the accumulator, and the higher byte of this product of this relation of this operation is stored in the B register. Okay. Similarly, we have the division operation. For division operation, we have the division instruction div AB. So here the content of the accumulator is divided by the content of the register B, and the quotient or the result obtained after this division operation is stored in register A, and if there are any remainder that is generated, it will be stored in the register B. Then we have the decimal adjust accumulator instruction DAA, where the content of the accumulator is adjusted for BCD uh, format. So once we perform an addition, and if we need to store the result obtained after the addition in the BCD format, we have to call upon or execute this particular instruction DAA. So the resultant of the addition, which was available in the accumulator, will be now formatted to the binary coded decimal format. Okay, so after this execution, the auxiliary carry flag will be affected. Then we have the increment by 1 and decrement by 1 instructions in the arithmetic instruction set. So increment destination means the destination that is specified in the instruction will be incremented by a value 1. So if I am using the instruction INCA, it means accumulator content will be incremented, and the updated value will be and the accumulator value will be updated after that. Okay, so it follows the register addressing mode. We can have the increment on registers also, so I can use INCRN, which performs incrementing of the register content specified content of the register specified, and the newly incremented value will be updated to that register itself. Then we have increment direct, that means the content which is available in the address specified in the instruction. Okay, so it will be incremented, and after that, that particular address locations content will be automatically updated with that incremented value. Then we have increment at the rate RI. This means the content that is pointed by the register, um, it will be going to that memory location. So the register R0 or R1 will be read. So the content obtained is treated as the memory address, and the processor goes to that particular memory address, and it looks for the content, and that content is incremented, and the uh, newly that incremented value is stored in that particular location itself. Okay. Then we have increment DPTR. The content of the data pointer register is incremented by 1, and the newly value is updated to that register on completion of the execution. Okay, so just the opposite of this increment operation, we have the decrement, where all these resources content will be decremented by 1. So in most of the cases, we need not go for decrementing the data pointer, we will be only going for incrementing. So we are not having that particular sequence of incrementing DPTR, the opposite of incrementing DPTR in the decrementing statement. Okay. So that's all about the various instructions that are grouped under the arithmetic instruction set of the 8051 microcontroller. Okay, so in the next class we will be discussing about the logical instruction set that is supported by the 8051 microcontroller. Thank you.